Hello students, today we will be studying about the refraction of light. You have the basic idea of how does light travel. You have studied the phenomena of reflection beforehand, and you also know about the terms like rectilinear propagation of light and so on. But when we studied reflection of light, all our phenomena, all our workings were limited to one single medium. Everything was happening either in air or in water. There were not a combination of mediums. So what will happen when there are more than one medium through which light travels? And that is when we need to know about refraction. Now I assume that you might have observed this everyday phenomena. This is a pretty common phenomena. Like if you take a glass of water and you fill it with water to a certain height, and after that say you are sitting on this side of the glass and you are looking at something which is on the other side of the glass. So suppose there is a flower like this. So there is a flower like this situated say on a flower vase in a table, and you are viewing that flower once directly through air, and then somehow you bring this glass of water in front of the flower. So how will the flower appear now? I assume you might have observed this, that the flower might appear a bit bigger in size, and the portions of the flower which you will be viewing through air, they won't be proportionate in size with the portion that you see through the glass of water. To make things simple, you can try this out. Take a glass of water, fill it with water, and then if you have a stick or a pen or a pencil, you put that pencil or put that pen inside the glass, and you will see the portion of the pen or the portion of the pencil which is inside the glass. Not only will it appear thicker than the portion which is outside, but also it will appear slightly bent than when it is outside. That is, I mean when it is in air. Now, does this mean that the pencil, once I am viewing it through water, has actually increased in thickness or has actually bent somewhere? The answer is no. The pencil remains as it is. There is no change in its size. It is not become a bent pencil from being a straight one. But just because we are viewing it through water, as a result of it, it appears to us as if these things have happened. And the way to correctly describe these things is refraction of light. So what does refraction tell us? Refraction says that when light is traveling from one transparent medium to another transparent medium, such that they have different optical densities, in that case light bends from its original path, and this phenomena is called refraction. Now here we have to keep in mind a certain things, like when we are trying to answer this type of questions, these words like transparent medium is very important. One transparent medium to another. So saying that it is traveling from one transparent to another transparent medium is very important, because if the medium is opaque, then we know light will not pass through it itself. So right now between me and this camera there is no obstacle except the air which is all around us, and so you can see me. But if I place a thick book or a thick cardboard in front of us between me and the camera, you won't be able to see me, because that would act as an opaque object. So opaque objects do not allow light to travel through them, and you cannot see what is behind them. So being transparent is one of the criteria, and second is that the two mediums will need to have different optical densities so that light actually bends from its path. So like, say this is a boundary that I am drawing. On this side I have air, and on this side I have water. So basically this say this is the area. Here I have air and here I have water. So I am drawing a expanded view of that. So I have air and water, and then if any ray of light is traveling from air towards water like this, and I will draw an imaginary perpendicular here. This imaginary perpendicular is perpendicular with the boundary that I have drawn, and say this angle is theta. The angle that this ray makes with the normal is theta. Then when it is traveling from air to water, it will bend from its path. It should have actually traveled along this straight line, but it will bend from its path, and the new angle is say phi. This is what refraction is. So it is traveling from one transparent medium, in this case air, to another transparent medium, which is water, and when it is traveling at the boundary separating the two media, that is separating air and water, the light is bending from its original path. The original path is shown by the dotted line, but actually light travels along the line that I have shown with the arrow. So this imaginary line, that is the normal, with the normal, during incidence light makes an angle theta, and during refraction light makes an angle phi. Theta here is called the angle of incidence and phi is called the angle of refraction. So this bending happens when there are two transparent mediums and their optical densities are different. Their optical densities are different. Now optical density is slightly different from density. What is the difference between optical density and density? Well, you know this, that if I have say water and kerosene, which one has got a greater or lower density? Water has a density higher than kerosene. So raw water, density of water is greater than density of kerosene. And that's pretty obvious, like if we take again a glass of water, pour it with water up to this height, and then if I pour 2 tablespoons of oil on it, we'll see that the oil floats on water. It does not sink to the bottom. So anything that's lighter will float and anything that denser will sink. So oil is lighter. So density of water is greater. But when we come to optical density, let me say optical density is OD, just an abbreviation. Then optical density of kerosene is greater than optical density of water. So when we say density, what do we mean? How do we define it? We say that density is mass per unit volume. So every unit volume of a substance, say 1 centimeter cube or 1 meter cube of a substance, how much matter is contained in it is density. But when we say optical density basically means that how freely light can travel through it. So if something has less optical density, it means it is more transparent, or light can easily travel through it. And if something has a greater optical density, that means the medium has got a lower transparency. It is more like opaque. So light will find difficulty in traveling through it, or it will take a greater time in traveling through it. So that is how density is different from optical density. And another thing that you can see from this example is, just because any substance has a greater density, it does not necessarily mean it will also have a greater optical density. One substance, like in this case water, can have greater density than oil, but when it comes to optical density, its optical density can be lower than that of oil. So there is no such correlation between density and optical density. Now you can see that a diagram has been drawn here. So let me just explain this diagram a bit more. So what are the different parts of this diagram? Well, on this side, say this is one media, this is air, and this is water. Light is traveling from air to water. This line here, this perpendicular line here, this one is known as normal. This is the boundary of the two medium, boundary of air and water. Angle, okay, let me name this light ray. This point is B, this point is A, and again this point is C. Then AB is called the incident ray, and BC is called the refracted ray. Okay, and we also have two angles. We have angle theta and phi. Theta is known as the angle of incidence, and phi is known as the angle of refraction. So these are the basic things. So light is traveling from air to water. AB is the incident ray, which is incident at the boundary of the two media, and there it is undergoing refraction, because of which then we get the ray BC, which is known as the refracted ray. The angles that this respective ray of light make with the normal are known as angle of incidence and angle of refraction. We have to keep in mind, when we measure angle of incidence, we will measure the angle which the incident ray makes with the normal. We will not consider this angle which it is making with the boundary. Similarly, when we say the angle of refraction, we will consider the angle which the ray is making with normal. We will not consider the other ray angle which it is making with the boundary. These are some basic terms associated with it, and these terms lead us to what we will now know as Snell's laws. You had studied about laws of reflection, you studied two laws of reflection. Just like that, here also there are two laws of refraction. The first law of refraction is almost similar to the law of reflection. The first law of refraction says that the incident ray, the refracted ray, and the normal at the point of incidence, this point B is my point of incidence. So the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. So in this case, all of them are lying in the plane of the board. So it means that if the incident ray comes like this onto the medium, the boundary separating the two medium, the refracted ray cannot come out of the plane of the board, or it cannot go inside. It cannot be like this or like this. It has to be, it can take any angle phi, but it has to remain within the plane of the board. That is what it means. And the second law of the refraction says that the sine of angle of incidence theta, it is also sometimes called I, and angle of refraction is called R, so I will write it like that. So sine of I divided by sine of R, the ratio of the sine of angle of incidence to sine of angle of R is a constant for any given pair of media, like in this case air and water. And the constant is known as refractive index of the second medium with respect to first medium. And this alphabet that I wrote here, it's spelled like this, mu. The pronunciation is mu. Mu represents the refractive index. Mu stands for the refractive index. So Snell's laws, the second law basically, which is actually called the Snell's law, it is named after a scientist Willebrord Snellius, who was a Dutch astronomer. So Snell's law tells us that the ratio of sine of angle of incidence to sine of angle of refraction is a constant for a given pair of media, and that this constant is equal to the refractive index of the second medium with respect to the first medium. So how do we know which medium is first, which is second? The medium in which the incident ray is present, that is the first medium, and the medium in which the refracted ray is present, that is the second medium. So when I say sin I by sin R is refractive index of second medium with respect to first, that means it is the refractive index of water with respect to air in this case. But if the mediums are different, if I take some water and glass, oil and water, and so on, this value will also vary. It is constant just for a given pair of media. For different pairs of media, the values are different. Now this question might come in your mind that why does refraction happen at all? Why? Why does the light bend from its original path? So if this is the boundary separating the two media, the light is traveling like this, it could have continued traveling like this. Why is it like bending either in this direction or in this direction? Why is this bending happening? The reason is that when I have two different media whose optical densities are also different, say this one has optical density 1, this has optical density 2. When I have two different media with different optical densities, in that case what happens is light and its speed changes. We know that the speed of light in vacuum is given by c equal to 3 into 10 to the power 8 meters per second. But that is just the speed of light in vacuum. For different mediums, the speed of light is different. If you take for example water, the speed of light is something like 2.25 into 10 to the power 8. In glass it is something like 2 into 10 to the power 8, and so on. So you see, as the mediums change, the values also change. So since in different media the speeds of light are also different, as a result their paths are also different. So in this medium, that is in the first medium, if I say this is air, light is traveling with 3 into 10 to the power 8. That is the speed of light in air. When it enters the second medium, say this is water, it is no longer traveling with 3 into 10 to the power 8, but now its speed has decreased. So because its speed has decreased, it will have a tendency to choose a shorter path, so that it takes less time, because ultimately light will have this tendency to reach the other end taking the same amount of time. Now we know that time is equal to distance by speed. So if you want to keep the time same and your speed has decreased, you will obviously want to decrease the distance as well, and that is why light bends from its original path. So the basic reason why light bends is that in different medium the speed of light is different, and in order to compensate for the change in speed, light compromises with its path and takes different path in different medium. Obviously again these mediums need to be transparent and they will have different optical densities.